Today I'll be explaining about limits. What are limits? So the limit is the value that f(x), a function, approaches as x approaches another value, right? So for example, we have this table here for some kind of graph, and I show that x, as it approaches, it goes 2.7, 2.8, 2.9. You'll see that it's getting closer and closer to 3, right? And as this happens, you can see that the function approaches 4, 3.7, 3.8, 3.9, 4, right? So we can say that as x approaches a value, gets closer and closer to that value, what happens to f(x)? Well, it gets closer and closer to 4. So we can write this as the limit of f(x) as x approaches 3 is 4, right? So sometimes this is intuitive, right? So the function itself might just end up at 4, but sometimes it always gets closer and closer and closer but never touches, right? But we can still write the limit of something is that number, right? So the general notation is like this: the limit of a function, and you write your function in here, as x approaches a number is what? Alright, so that's your general notation. So now we'll look at some examples. The most basic one is so to find the limit of something, the most basic way is just to sub in the value of x, right? So here my function is x plus 1, which is a straight line. So I'll say limit of x plus 1 as x approaches 2, I sub it in, I get 2 plus 1, and it's 3. And if you check out the graph, it is 3, like exactly that number. So this is all fine and dandy, right? So if you can, step 1 is to try to substitute, and if it works out, it's alright. Sometimes when you substitute, it doesn't work out, so stuff like this happens, right? So here you can see limit of this function as x approaches to 3. So I'll try to substitute first, okay? Let's see. If you substitute 3 to the top here, well, this becomes 9, substitute 3 here becomes 9, 6. But if you substitute 3 to the bottom here, you'll see that 3 minus 3 becomes 0. And you can't divide a 0, right? So that becomes an undefined function. So what you got to do is try to find a way to reduce this to a way that can be defined, okay? So for equations like this, usually what you do is try factorize them. If I take this out, I factorize it into x plus 1, x minus 3, right? And as you can see, I can actually cancel these two out. So I'm left with the function is x plus 1. And I can just sub in 3 here. Sorry, I forgot the arrow. Sub in 3 into here, and it becomes 3 plus 1, and I end up at 4, right? So this function, as I approach 3 in x, the y, or the f(x), approaches 4, right? So that's how you do this. Okay, so step 1, try to sub in. Step 2, try to factorize if you can't sub in. Okay, what else? What if my limit is x approaches infinity, right? So let's see, I have this function, okay, 1 over x. It's a reciprocal graph. It goes like this. As x approaches infinity, which means that the x, it keeps going and going and going, as you can see, it's going to get closer and closer and closer to 0, right? So whenever your x is at the bottom, it's a denominator, right? As x approaches infinity, logically, if you divide something really, really big, you get something really, really small. So we approximate that as 0. So whenever your x is at the bottom and it's infinity, the limit is 0, okay? So this one will keep going, almost close, very close to y equals 0. What else? What if limit x equals to 0 and it's a denominator? So there's no way you can factorize this function anymore, right? It's stuck like this. So if x equals to 0 and it gets closer and closer, you'll see that it approaches a certain value, but at that very moment, there's actually no function. So it's an empty hole, and we write that as an empty hole on the graph. So it's called undefined, right? So that's what happens if you really can't do anything. But always try to solve it. Don't just write undefined just because you can't find the answer. Let's try a question. Limit of this function as r, which is the variable, approaches infinity, right? So you can just try to sub in infinity here, but that wouldn't really work out. One shortcut you can remember is that the limit of something when the variable is on the denominator, right, is always 0. So try to make this into a form where you can reduce it to 0. For example, you can see that there's r here, right? So my step is to divide all the terms here by the highest variable. And the highest variable here is r, right? If my highest variable was r squared, I divide everything by r squared, right? Just to get rid of that. So now I have everything at the bottom, right? So 5 divided by r, 2 divided by r. And as you know, as it approaches infinity, this whole value becomes 0. So now we're left with 0 plus 3 divided by 0 plus 5, right? Reduce from here. And now I can just do maths and it becomes 3 over 5. So the limit of this as it approaches infinity is 3 over 5. So limits is useful in differentiation because, as you can see, this shows a rate of change, right? As you're changing on the x-axis, you're also changing on the y-axis. So a limit is what you approach, right? And this is good for approximating very, very small values. For example, on a graph, when you want to find tangents and stuff, you can draw a straight line on a curved graph, like that, right? So there are actually 2 points that are very, very close to each other. And how to approximate points that are very close to each other? Using limits, right? So this is the basis of all differentiation.